I just wanted to make another video showing you what you could have done if you weren't demanded to use a critical region. So if it just said comment on the observation using this sample and you didn't have to use a critical region, I wouldn't actually use a critical region because the p-value method is going to be a bit quicker. So with the p-value method, we're going to do exactly the same thing and we're going to assume that H0 is true. So that is d bar follows a normal distribution. If h bar is true, then the mean is going to be, if h0 is true, then the mean is going to be that. And the variance of d bar, the sample mean, is going to be the variance of d divided by the sample size, which is 50. So again, we would draw out this distribution. And on our horizontal axis, we've got d bar, and if h0 is true, then the mean is this. And we know that we saw a d bar value of 0.587. So that's our sample mean, 0.587. And what we want to do is we want to basically work out, are we in the final 0.5% of the distribution, the right 0.5%, and it's 0.5% because remember from the previous video that we want 0.5% in each tail. So one way of doing that would be to work out this area to the right of us. So let's work out the probability of d bar being greater than 0.587. We're going to go to statistics mode, normal distribution, and CD because we want the area, and we want to find the area to the right of 0.587. So we're going to put our lower as 0.587 and our upper as a really big number, infinity. And remember, this is the variance, this value here. So the standard deviation of d bar is going to be the square root of this fraction, which is 0.015 over root 50. So let's put that into our calculators. 0.015 divided by root 50. And mu is 0.58 because that's our under H0, that's what our mu is. So we get that probability is this probability here. So that's 0.048%. So we've got to work out, are we in the right 0.5% of the distribution? Because if we are, then we're going to say that d bar that we saw, this should say d bar is big enough to suggest that we're in the critical region. Well, if we know to the right of us is 0.048%, then the critical region must be to the left of us, our critical value. So that means that we are in the final 0.5%, because to the right of our critical value has to be a total probability of 0.5%. So we must be in here. So this is what's called our p-value, and sometimes you might see reject H0 if the p-value is less than the significance level. And this logic is why we're rejecting that, because it basically means that you must be in the critical region. So we're going to write that to the examiner why that is. So 0.048% is less than 0.5%. So we're in the right 0.5% of the distribution. So that means we're in the critical region and we're going to reject H0 like we did before with the critical region method. And then you would do the same conclusion as we made before.